assignment sheet for the week, and there is a 2-day test on these identities. So Thursday's test is about 25 minutes, and when you come into class Thursday, I'll answer questions. We'll go through a couple of problems. But Thursday is the simplifying part, which is what we did last week. And there are, I'd say Thursdays is like a little easier. So the worksheet that you just turned into me, that would be like your test on Thursday. So there's a couple of problems on there, just simplifying, as I said, like 25 minutes. Friday's portion is going to be similar to what we do today, tomorrow, and Wednesday. And they're a little more involved. You have 5 problems on Friday, and you'll have all period to work through those 5 problems. Some of you will not be here because you're juniors and you're going to the college fair. You'll just, I'm sorry, have to make it up. But I only have this class that I'll be missing a handful of juniors, and it doesn't apply to anybody else. So you just have to make it up. Before school, after school, whenever you can find time in your questions on that.
I could probably do it like that day.
That will be fine. Yep. All right, so if you look at example 1, it says to verify, which just means that we're going to try and show that we can get the one side to become the other. You don't cross the equal sign. So we're not making this an equation. We're not moving things to the other side. You're picking a side, sticking with the side, and trying to get it equal to the other side. So if you look here at this case, we're trying to make it equal sine squared. That's the answer. So we have secant squared minus 1 divided by the secant squared. Can those secant squares just magically cancel? No. Because, I know, it'd be nice, but the top is a quantity. A quantity is grouped together with a plus or a minus. You can't separate them. Is there an identity that we can use to try and change it? So, what identity can we use to try and change it?
1 plus 10 squared equals secant squared.
Yeah. So, the identity 1 plus tangent squared equals secant squared. If we just bump this little 1 to the other side, we can take this part out and replace it with tangent squared. So now we have tangent squared over secant squared. Gabby, what else can we do?
Could we make tangent squared sine over cosine and then secant squared 1 over cosine and then cross out the cosine?
Perfect. So she said, let's continue and keep changing using identities. So tangent squared, the quotient identity says it could be sine squared over cosine squared. And then secant squared, the reciprocal identity, it could be 1 over cosine. So take notice, I'm not writing that other side. Like, that's just, our goal is to try and to get it to equal. I'm not really worried about it. As long as we get to equal that, then we're good to go. And then she said cross out the cosines. And what we have left is just a sine squared divided by 1. But that does make sine squared. So I got my answer once we simplify it down to sine squared. So you know what you're trying to get to, which is nice about these problems. You know what the answer is. So looking at number 2, this one looks a little more interesting. So we have a tangent plus a cotangent, and then on the other side we have secant times cosecant. So we're trying to get the plus sign to go away and to become multiplying the 2 terms in the end. So it starts on the left side again. So we'll start here. This is going to be what we're trying to get it to equal. But look at tangent plus cotangent. So again, somehow we try and need to make this become multiplication. At the end, our goal is to get it to be 2 functions being multiplied together. But those functions are supposed to be secant and cosecant. So what could you do with tangent and cotangent? Yeah.
So I changed it into sine over cosine x plus cosine over sine x.
Yeah, so quotient identity, sine over cosine. And then the cotangent is cosine over sine. So that's looking at the quotient identity. That is an addition sign still in the middle. So it's not multiplication. They don't cancel and get the number 1. We're not even supposed to make it 1. So don't cancel those. So if we focus on the addition sign, Hannah, what would you you do?
Then I made them have a common denominator. So for the sine over cosine, I multiplied the bottom by sine and top by sine.
Nice.
And then for the other one, I multiplied it the bottom by cosine and top by cosine.
So common denominator. You got two fractions, you're trying to add them together. We have to get a common denominator. And one has a sine in it, the other one has a cosine, so we need to use that information there. So now we have sine times sine, which is sine squared. Sure, what's going on with my board? Yeah.
Yeah.
We have the addition sign, and then we have a cosine squared. And then on the bottom, we have sine times cosine. Remember, common denominator, the goal is for us to keep, you don't lose the denominator, it stays in the problem. So it's there, but now we can pull them together as one fraction. So that's a good thing, to be able to pull things together as one fraction instead of having two separate. That's how we can try and change something to multiplication. What is sine squared plus cosine squared? 1. So now we have 1 over sine times cosine, which is the same thing as having 1 over the sine times 1 over the cosine. That means the same exact thing. So 1 over sine times cosine is really having a 1 over each of those individually. So 1 over the sine becomes cosecant. 1 over the cosine is the secant. Is that the same thing as the secant times the cosecant? Yes. So if you have cosecant times secant, that really means secant times cosecant. Multiplication is commutative, it can switch back and forth. So we've now showed that this, or verified, that the left side can become secant times cosecant. Question. So if you look at example 3,
Can you simplify the inside?
so example 3 says the secant or plus the tangent. So we have two functions. But on the other side, you have cosine divided by 1 minus sine. This is a problem where I would say the right side might be easier than the left. So you can pick a side. And if you choose the left side and you don't get somewhere, just stop. Maybe try to work with the other side. You don't always have to use the left side and make it equal to the right.
Are we allowed to simplify it, go with one side, but then still solve the
No.
other side? We can't do that.
No. So once you choose a side,
Okay.
you cannot then hop to the other side and work through that side as well.
Okay.
So you've got to choose a side and commit to that side and work down until you get it to equal the other side. So there's no crossing the equal sign, there's no moving things, you can't start one and start the other.
Alright.
So see if you can pick a side. I'm going to show you how both sides work. But choose a side. Maybe you see that like what you could do with the right side instead of the left side. We'll go through both ways. Yes, for the right side. How many of you use the right or the left side? Did anybody use the left side?
I tried.
Nobody wanted to do the left side? Not really, no.
If
I mean, it's the same. You do the same thing.
if I could have, or if you could have simplified the right side, it would have been so much easier.
So what do you do with the right side?
Conjugates.
Yeah, so you're going to use the conjugate on the right side. So if we have 1 plus sign, we're multiplying it by 1 minus sign. How about we have 1 minus sign, we're multiplying it by 1 plus sign. There we go. So I'm going to leave the top as it is. Cosine y, 1 plus sine. Josh, what's the bottom become when you multiply those together? Right. Okay, so we multiplied by the conjugate. We now have cosine 1 plus sine. And then on the bottom, when you FOIL, you get 1 minus sine squared. Lauren, what is 1 minus sine squared? Cosine squared. Yeah, so we have a cosine 1 plus sine. And then on the bottom, this is the identity, Pythagorean identity, sine squared plus cosine squared equals 1. So that becomes cosine squared. Lauren, what happens then? Right, so when you have a cosine and a cosine squared, it's like having a y and a y squared. They can cancel. So there's a 1 on the top, it's now gone. There were 2 on the bottom, now there's 1. And so what we have is 1 plus sine divided by cosine. But remember, our goal is to get secant plus tangent. So what do you do with 1 plus sine divided by cosine, Carrie?
Separate them into two different fractions.
Yeah. So if you have a denominator with a single piece in it, but 2 parts in the numerator, you're allowed to separate it. So we could take 1 over the cosine, make it an addition sign, and then we have sine over cosine. So it is a common denominator. Those 2 statements are the same, but once you separate them, then you have now 2 separate parts. And it's addition. So carry 1 over the cosine is,
Secant y,
and sine over the cosine is
tangent.
tangent y. All right, so before you move on, I want you to try and do the other side. We can work through it together. But we're going to try and do that other side as well.
I think it's gonna be easier to
Yeah, you kind of know now. All right, so the secant you can change into 1 over cosine. The tangent is sine over cosine. Colin, you started this one. Is that how you started it?
Yeah.
And then you can add them together because they already have a common denominator. And if you look, we have that same step. Those steps are the same. So I have 1 plus sine over cosine, 1 plus sine over cosine. Except that you have to still continue on because the goal is to get the cosine on the top and 1 minus sine on the bottom. What do you mean the opposite of the conjugate?
Like, could you multiply like the top, but there could be like 1 minus sign.
Yeah, so the conjugate can be applied anywhere. It doesn't always have to be the denominator. The conjugate in trig, the whole goal is to use the conjugate to get something that's squared. So it happens that most of the time we've done it with the denominator, but we're actually going to use the conjugate in the numerator this time. So we're going to multiply by 1 minus sine. And that's how we get that 1 minus sine in the bottom of the fraction. So now the top says 1 minus sine squared using the conjugate. The bottom, not multiplying the bottom through, keeping them separate. So you can kind of see how the 2 sides are very similar. They just kind of work the opposite direction. So 1 minus sine squared is cosine squared. On the bottom we have cosine y, 1 minus sine. And again, we had that step where they cancel. So this time the cosine squared is on the top. It's going to cancel and just give you one of them. And now the bottom cosine is completely gone. But you can see how like both of them, they are similar. They're just working through backwards. So my answer now, I have a cosine on the top and 1 minus sine on the bottom. But now we've worked through it both ways. So you really can pick a side. But no, you can't work halfway through one and halfway through the other and just say like, oh look, I got them to meet. So you must choose a side and work the whole way through the side. Questions? So look at example 4. Pick a side. And this one, either side would work. So choose one of the sides. Sometimes one side never works. It just won't, you just can't sometimes get something to change. So there are times where you just have to pick the left side. But in this case, both of them work again. So try and like just see what would you do. Pick a side. Try and decide what to do with that.
You might have to factor. I think there's more to do with the right side.
How you start?
Probably not.
Did you factor in the sine?
Yeah, but what did you do?
Watch the cosine.
I like this stuff.
Oh, you took out a cosine. Oh, see more now. That's smart.
So it seems like a lot of people are choosing the right side again. Dylan, what'd you do with the right side?
I took out
Yeah, so if you take a cosine to the 4th out, that's what he meant. Dylan, what do you get when you factor that out?
1 minus cosine squared.
And then we still have this sine in the back. Squeeze that guy in there. And then Dylan, 1 minus cosine squared is? Dylan, 1 minus cosine squared? Is sine squared. And then we have a cosine to the 4th. Adding the exponents of sine, there are 2 from the identity. There's a third one. So now we have cubed. So now we have sine cubed, cosine to the 4th. All right, how do you do with the other side?
I don't
I don't even want to look at it.
I think it's one of those, I think it's one of those sides that just doesn't.
Okay, so Carrie said take out a sign. So there's really not factoring because factoring involves having 2 things, 3 things. But Carrie, you're actually right. Instead of doing factoring, if you just try and pull a couple of pieces apart. So if you have sine cubed, he said, well, I was just going to try and do the other thing backwards. You can say sine cubed really means sine times sine squared, and then with that cosine. So yeah, it kind of is like doing the other one, but backwards. Carrie, if we do the other one using that same information, sine squared becomes
1 minus cosine squared.
1 minus cosine squared.
That easy.
There's still a cosine to the 4th. We now have that single sine by itself. And then if you distribute, instead of factoring it, if you distribute the cosine to the 4th through. So we have the sine in the front. Cosine to the 4th times 1 is cosine to the 4th. And then minus cosine cosine to the 6. So you're allowed to separate powers. You can split a power up. I think we did that on last Thursday too. So I have one extra little review that we're going to do, or extra problems.
So we get points for this? Extra credit points?
Extra.
That's what I'm saying.
This is a fun.
That's what I heard.
Yeah, that's exactly there. What's an extra credit point? Was that resonating?
It's something here that will be.
Yeah.
I have like 80 those.
I don't know how that works. I don't know.
Well, he also makes like homework like pages worth like 70.
That's crazy. Crazy. You have a lot of points in the class, I guess. Yeah. Yeah. So the reason I wanted to give this out is, as Colin said, we had this problem similar last week that was in the homework. It was number 81. I think it was last Thursday. So I wanted to go through it again, just so that you could kind of see. My spinning wheel is no longer spinning; it's just frozen.
Nice. That's like the ultimate like.
The wind stuff.
That is the bad.
You should get a
So number 1 says to use use trigonometric substitution, which works like algebraic substitution, where x is equal to. Oh, hey.
Yeah.
I know, right? Woohoo! Maybe. So x is equal to 5 times the sine of theta, and then it gives you the fact that your angle is between 0 and pi over 2. That's just so that in the end, we don't worry about keeping a plus or minus there. It's just going to be a positive answer. So that information is given to let you know that the angle is in the first quadrant. All answers are positive in the first quadrant. And then we're going to express the square root of 25 minus x squared as a trigonometric function. So how do you start with the trigonometric substitution? Dylan? Yeah, you plug it in. So we have 25, and then instead of x squared, we have 5 sine theta. Remember, that whole thing is squared. When you plug it in, if x is squared, whatever you plug in has to be squared. So Dylan, that really means that we have the square root of.
25 minus 25 sine squared.
Right. Don't forget that the 5 is squared as well as the sine. So you're squaring both of those numbers when you plug something in for x. How do you simplify that? Dylan?
You can take the square root of 25, so it would be 5 and the square root of 1 minus sine squared.
Excellent. So the 25, factoring it out, and then we have 1 minus sine squared. So he said the 25 just becomes a 5, because the square root of 25 is 5. You can take that because they're being multiplied. So you're allowed to just take the square root of 25 and pull it out. So you're left with then the 1 minus sine squared. So we just pulled the number out. God bless you. It's not quite simplified yet. We still have a square root in here. We've still got 1 minus sine squared. Yeah, so we can use an identity. 1 minus sine squared is cosine squared. So now we have 5 and then the square root of cosine squared. Yeah, and the square root of cosine squared is just like the square root of x squared. They cancel. And you just get 5 times cosine. So now we have 5 times cosine. Questions? So don't let the wording confuse you. Substitute it in. Really, you're just trying to simplify it. And it's a positive. We're not worrying about the plus or minus, even though we took a square root. And that's because the information at the top specifically saying the angle is between 0 and pi over 2. So you're not going to have a plus or minus in the answer. The last one on here wants you to rewrite this as a fraction. Or not as a fraction. It is a fraction. And it doesn't give you an answer, so this is one of the simplifying problems, so you're not going to have an answer. But we have 3 divided by the secant minus the tangent. Josh, what's one thing you can do to try and get something so that it's not in fraction form? Oh, you made the bottom into more fractions?
Bro.
More fractions, okay.
Said, "Alright, let me go backwards."
Josh, you can keep working that way. So if our goal is to get it out of a fraction, or you could just do the conjugate. Josh, you are not wrong.
I got there, I just.
Okay, yeah, I was gonna say, it's not wrong whatsoever. It just might be a couple extra steps. So again, there's multiple ways to work through a problem. You might just choose a process that might be a couple extra steps. But we can use the conjugate, which would be the secant plus the tangent. So on the top, I'm going to just leave the 3 outside. And then the bottom, when you multiply that, secant times secant is secant squared. Our middle terms cancel because we're using conjugates. And then negative tangent and tangent is negative tangent squared. And then Dylan said it's going to equal 1 because 1 plus the tangent squared is equal to the secant squared. Well, if I subtract tangent, the secant squared minus the tangent squared is just equal to 1. So this whole denominator is equal to 1. That means we have a 3 and then the secant plus the tangent. And you can keep the 3 out. You don't have to distribute it through. Things that are factored are actually simplified. Questions? So your homework tonight, again, don't follow the book directions. They're going to give you 2 equations. You just need to put those 2 equations to look like the ones that we've done. So set them equal to each other for 21, 23, 27. So make sure you're just taking those 2 equations and making it like a verifying problem. The left side equals the right side. Don't do the rest of what the book says. Anybody interested in doing 17 or 20? Brenton and Dylan? 17 Brenton, Dylan 20.
We need